Welcome everyone to the 2020 APEC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions you can, and all sessions will be available to replay as many times you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, Exadata Cloud at Customer Generation 2, Oracle Cloud in your data center by Gleb Otochkin. Please feel free to write questions at any time during your session by using the Q&A tab in the Zoom webinar, and Gleb will be answering them at the end of the session. If any issues during the presentation, please contact me as the moderator, but anytime by using the chat tab of the Zoom webinar. Just a recap, you can make questions to Gleb about his session, and he will answer at the end by using the Q&A option on your Zoom webinar. And you can also contact me for any technical issues of anything else non-related to the presentation itself by using the chat option on Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Gleb Otochkin. Gleb, I stop sharing right now and you can start sharing, and I will put myself in mute.
Great. Thank you very much, Francisco. All right, let's start slideshow. And show has begun. All right. Welcome again. We are going to discuss about Exadata Cloud at Customer Generation 2 and what you can expect, what it is, what exactly you have behind the scenes, what kind of service you are getting, how you approach for deployment, how you approach for migration, and what kind of challenges I saw in the field when I was helping different customers with adopting the new infrastructure, Generation 1 and Generation 2. Couple of words about myself. My name is Gleb Otochkin. I'm working as a senior cloud architect in Eclipse Solutions, and we're a Canadian company. This is Ottawa. I'm running a lot in Ottawa during any weather, any cold or warm. We have pretty cold winters here. I'm working with engineering systems since 2010. With Oracle RAC since Oracle 9. And so I spent quite a bit of time with performance tuning and other Oracle technologies, including big data and cloud. Here my blog, my email, and my Twitter handle. Please shoot me an email or post question to Twitter if you have any questions or need any help with Exadata, ExaCC, or any other Oracle-related technologies. So that's all about me, and let's go forward to the presentation. My safe harbor, Oracle likes to put safe harbor statement. I'm putting my hometown harbor. It is the sightseeing I was able to see every day from my kitchen window in my hometown. Now I'm living far from sea, and it is sometimes a little bit sad. Let's talk about different types of cloud, just a couple of minutes, not more than that. And for example, on-prem, we have some kind of challenges which differentiate on-prem solution from any public cloud. Our elasticity on-prem and scalability is limited by existing infrastructure. The budget usually it is capex budget with capital investment. It is I would call it high maintenance because you have to maintain everything: network, servers, infrastructure, electricity, cooling, and everything in your data center. The deployment cycle usually longer than in the public cloud because you have to go through procurement, through budget, through getting the hardware, setting up, configuring the hardware, and installing software. As a result, the business agility is low. Your licensing is fully your responsibility. You are responsible to maintain licensing and be careful that it is exactly the same as your deployment. But you are getting the full control and pretty low latency access because your application is just next to your database. In the public cloud, from other side, you have much more elasticity and scalability. So you can scale up or scale out and scale down when you need it. The budget, it is operational budget, OpEx. Um, I would call it low maintenance because you don't need to maintain the storage, infrastructure, network. Everything is maintained for you by operational team of a cloud vendor. Short deployment cycle. To deploy anything in the public cloud, you need to just push the button. Literally, sometimes just push the button. As a result, business agility is high, and licensing sometimes are floated to the cloud vendor for some kind of license included model when you pay for subscription fee and your license is already inside that subscription fee. Potentially, you can have network overhead when you work with your application or some other integration points which are still on your PEM environment in your data center. And in that case, access between the, for example, your database and some integration point, analytic data center could be impacted by network. And you have only partial control for deployment, not full control. When we have combination of public and private solution, we call it hybrid cloud. It is a combination of both sides with shared responsibilities. You have to have orchestration layer for both of them, which combines and can manage both solution in the public and in the private cloud. You still have subscription price model, and you can scale up and scale down using that subscription price model. Exadata Cloud at Customer is a hybrid. It is cloud service, but deployed in your data center. So you have hardware deployed in your data center with software which manages it from public cloud. That is your Exadata Cloud at Customer. Let's talk a little bit about Exadata data platform as it is. So if you are not familiar with Exadata, the Exadata machine is a hardware created to run Oracle databases. That probably simplest explanation. So of course it is sophisticated hardware and software working together. You have the same database servers, x86, 64 database servers. For X8M, it is Intel Cascade Lake, 2 sockets, 24 cores each, with default 384 gigabytes of memory. So depending from configuration, you can have up to 8 database servers per rack. It is for full rack, for example. It is connected to storage layer, and storage layer is the same Intel Cascade Lake, 2 socket servers, but with 16 core CPUs and 96 gigabyte of memory. What it has in comparison with database servers, it has a lot of disks and flash. For each database, storage cell, you have 12 14 terabyte disks inside, plus 25 terabytes of flash and 1.5 terabyte of persistent memory. So in terms of access to that layers, you have the fastest access you are getting to persistent memory. It is most least latency to get data from the persistent memory. Then you have a flash, and then you have a disks. So the 3 tiers of storage on each storage cell servers. So, and it is connected through RDMA converged Ethernet, so RoCE network. What it means, RDMA, it is remote direct memory access. And the latency with remote direct memory access is 10 times shorter than direct through normal channel through InfiniBand. So the latest generation of Exadata is 10 times in case of access to data faster than the previous generation, X8. It is extremely fast database machine with storage servers capable to offload part of the load from the database servers. For example, if you have full table scan for a table, and for example, you have a condition like filter of the data, like column X equal value A, and you have direct path full access for the table in your SQL path, that information will be offloaded to cell storage boxes, and cell storage boxes will try to outfilter data you don't need and send to compute node to buffer cache data you only need. It can reduce significantly, dramatically improve your performance for your database. Also, you have some other options. You have storage indexes, you have flash memory, and all that technologies are created to improve performance. So you probably, I'm not going to spend the whole presentation explaining the Exadata, but it's worth to watch some presentation from Exadata group from Oracle. So that is we are getting as Exadata. What we are getting in the cloud. In the cloud, we have two services. One of them is ExaCS, Exadata Cloud Service, and another one, ExaCC, Exadata Cloud at Customer, which we are going to talk today. So the difference between them, the ExaCS, it is public cloud version of ExaCC, or you can say another other way around. ExaCC, it is hybrid version of public cloud ExaCS. It can be deployed in fixed or flexible shapes. The flexible shapes, when you choose by default, historically, you can choose several shapes for your Exadata. It is the quarter rack when you have two compute nodes and 3 storage cells. It is minimum configuration. Then you have half rack when you have twice more storage cells and compute nodes. And then you have full rack with 8 compute servers and 14 storage cells. In cloud, instead of 14 storage cells, you have 12, 6, and 3, that gradation. But again, those are fixed shapes. And historically, you could choose only fixed shapes. I want quarter rack, half rack, or full rack. Since probably a couple of weeks ago, I don't remember exact date, but really recently, Oracle published that now they accept flexible shapes in Exadata Cloud Service for X8M deployment. So, and you can choose, for example, 2 compute nodes and 4 or 5 storage cells if you need more storage for your environment. That is big leap forward. On ExaCS, you still have only fixed shapes so far. Oracle responsible for infrastructure on ExaCS and ExaCC. ExaCS has a little bit more sophisticated and advanced interface in the public cloud than ExaCC, but interface for ExaCC is gaining pretty fast and active development, and probably will be roughly the same for both services. You have to pay non-metered fee for infrastructure. For example, for QuarterRack, you pay $15,000 per month. It is fixed price. You pay for infrastructure itself, like for renting infrastructure. It doesn't matter how many CPUs you use. And on top of that, you have to pay for OCPU per usage, and it is billed by seconds. You used 4 OCPU for 2 hours, you pay for that. You use 6 OCPU on some period of time, you pay for 6. So the same model on ExaCC. The difference, ExaCC and Exadata. So on top of the same database servers, Rocky network, and storage cells, you are getting control plane servers on top of the rack, and they are to communicate, create a bridge between on-prem deployment of your ExaCS hardware, because it is in your data center, and through control plane servers, you are connected to Oracle Cloud, and you can manage your ExaCC from Oracle Public Cloud by bridge executed by control plane servers. You have the database servers, like for QuarterRack, you have the same 2 database servers as on Exadata, but you remember that on Exadata, you have 2 socket, 24 cores. In ExaCC, you have more cores. You have the same 2, but by 26 cores CPUs. You have more memory, by default 1.4 terabyte of memory per server. And on storage servers, again, you have more CPU. Instead of 16 core CPU, you have 24 core CPU there. But the flash and disks and persistent memory are the same. And on ExaCC, if you use license included model, when everything is included to your subscription, then you are getting all database option and all Exadata features. I'll talk a little bit about that on later slides. Let's leave it for now. Here are the numbers, and the base system is quite different from quarter-rack, half-rack, and full-rack. The base system has the same number of servers like quarter-rack, but half of CPU and half of storage is disabled there. You don't have it. So and another thing, if for quarter-rack, half-rack, and full-rack, you know what you're getting, X8 or X8M. For base system, if you order base system, you probably can get X8, but can get X7 as well. So that is not promised for you. In reality, I would not recommend base system to anyone. I would prefer to have proper quarter-rack environment instead. And speaking about the numbers, if you have a look to usable disk storage, you can see that for quarter-rack, you have 150 terabyte of usable storage. It is already with triple redundancy. It is not raw storage. It is what you are getting for environment. Let's go forward. Let's talk about ExaCC pros and cons really quick. So what are the benefits of having ExaCC? First, you are getting power of Exadata, and you don't need to buy one. You are renting Exadata, and it is the latest and greatest X8M. You can have different flexible layout for VM cluster. It is Exadata with VM configuration, so you have access to VM on top of Exadata environment, and you have full control on VM level. So you have root access. You can install your third-party software if it doesn't break existing Oracle software. You don't need to do maintenance on low level. So Oracle is doing patching and maintenance and hardware monitoring for all the hardware components and hypervisor level of your compute machine, like DOM0 for OVM and KVM. On the same time, you have low latency for network layer because it is in your data center right next to your application servers. The data are staying in your data center, and you are getting some automation tool for your operations, like patching tool, some tool to perform some database actions as well. And you have per second CPU billing, so you can flexible increase your CPU capacity and decrease it. If you have spike type workload like seasonal, or even you have, for example, I need more CPU from 9 a.m. to 3 p.m. You can probably in advance increase number of CPU from 9 to 3 and then go down, reducing your CPU footprint and how much you pay for that usage. And you are getting, with license included, full set of Oracle options. It means all options, enterprise edition options, plus all Oracle packs included to subscription fee. And you have high availability. Exadata doesn't have single point of failure. Everything is redundant in Exadata. Compute nodes, redundant. Storage cells, redundant. Network switches, redundant. Even plain servers connecting you to the cloud are redundant. You have 2 of them. But that is good stuff. What kind of concerns? Sometimes some people don't like OpEx model, operational budget model, when you pay subscription fee instead of capital investment. That is financial concern. If you try to bring your own license, which you can technically use, you can use your own license with ExaCC, you lost ability to elastically scale up and scale down and manage your cost. The reason you cannot bring your own license with license included inside the same VM cluster. You still have some maintenance to do. You still patch operation system on VM, grid infrastructure, and databases. That is your responsibility. You have quite a few new options, and as Oracle required to encrypt your data on any cloud environment, on any cloud database as a service, you have to adopt transparent data encryption. And I found particularly transparent data encryption in combination with multi-tenant environment creates most challenges for many DBAs who were not used to that technology. Control is kind of limited. You have full access to VMs, but you have no visibility or access to self-storage boxes, network switches, or DOM0 hypervisor to hardware layer at all. Non-flexible rack configuration. It means you have to choose one of 4 shapes. It is what you are presented. And limited cloud interface. What I say limited, you have only few options so far, what you can do from the cloud interface. But that, as I said, it is in active development and it is gaining the same level as Oracle Exadata Cloud service. I believe it will be soon the same level of performance and service. Couple of different options: license included versus bring your own license. With license included, you are getting all Oracle Enterprise Edition extreme performance features in memory, database, partition, advanced compression, advanced security, and all Oracle Enterprise Edition options are included. All packs like tuning packs and everything else. And of course, you are getting all Exadata features included. You can use elastic workload. You can scale up, scale down CPU according to your need, and you pay by second, of course, with minimum allocation 1 minute. If you scale up, you cannot scale up for 30 seconds and scale down. No, it is not going to work. You have to scale up at least 1 minute and then scale down. So you will be charged for at least for 1 minute. And technically, in reality, it takes usually about 30 seconds up to the minutes to scale up anyway. So it is technically, probably it's not possible to scale up and scale down in time less than 1 minute. Bring your own license. What you are getting for free included, it is because you are going to the cloud, it is transparent data encryption, data masking and subsetting, diagnostic and tuning pack, real application testing, and all Exadata features. One processor license equal to OCPU, which is quite normal considering multiplication factor for x86 CPU. Autonomous, couple of words. We are not going to talk about autonomous deployment here. I personally don't have experience with autonomous on ExaCC. It is available. It is relatively the same as dedicated autonomous in Oracle Cloud infrastructure. You cannot mix autonomous and non-autonomous deployment on the same machine. Autonomous is taking entire rack by itself, and it is running one or two or up to 12 autonomous container databases. And you can have only one autonomous VM cluster on Exadata infrastructure. So you cannot mix two different modes. You cannot just try autonomous on your ExaCC. You can use either autonomous or not. That's no middle ground. You can have maximum 12 autonomous container databases with 100 autonomous PDBs inside for 1/4 rack. For half rack, you have 200, and for full rack, you have 400 PDBs as a limit. The reason is quite simple. It doesn't use over provisioning. So for one PDB, autonomous PDB, you have to allocate at least one CPU, right? And you have 100 CPU. If we go back to our specs, we have 100 OCPU per quarter rack. That dictates number of autonomous databases. Let's talk about capacity planning, how we approach to Exadata. So when you decide, it make business case to move our databases, for example, from AIX, from Sun Solaris Spark to Exadata, consolidate, and everything probably will be better in case of money, because when you switch, sometimes the support fee you are paying 23% of your licensing fee to Oracle, whether you use it or not, sometimes probably you don't need so much CPU licenses, and that can make good business case for you. You need to understand how much you pay for on-prem licenses, how you can consolidate and reduce CPU allocation depending from seasonal or daily workload, and then create a business case. To properly plan the capacity of required ExaCC environment, you have to capture workload. Usually you use OracleMania. You can find it on GitHub. It is still there. And work with Oracle team to understand. So Oracle team will ask you to run the script to gather information. More period of time you gather information using OracleMania, better for you, because it will provide more data to Oracle and they will better understand your performance requirements. So you supply OracleMania reports, Oracle will come back and say, here what we have, here your IOPS, here your storage requirement, here your CPU requirements. We recommend such shape for ExaCC because we believe it will be enough for your workload. So what you need to remember, when you talk about storage, include temp and FRA. Also keep in mind that since you are moving to real application cluster, if now you are not in real application cluster, it will require another undoable space, and maybe undo should be doubled in some cases. Memory, you have to keep in mind PGA and SGA altogether, because you have to have both sufficient memory to feed both of them. And if in some cases SGA can be reduced because you rely to Exadata technology to offload some load from buffer cache, for example, your PGA still probably will be the same anyway. The program global area for your SQL queries and sorting everything else probably will require the same memory. You have to keep in mind that not only physical but also logical I/O, because logical I/O, it is CPU load and it depends. It is not so easy. Number of containers. If you plan to have only 10 OCPU for your VM cluster and want to deploy 40 container databases, it is probably not going to work. By default, Oracle hard-coded, you can create up to 2 databases per OCPU. It means if you deploy 10 OCPU on your cluster, you can create 20 databases. Of course, you have workaround. You can bump up CPU to 20 and create database and then scale down it back to 10 CPU. That is possible, or you can shut down some databases, then create and then start it back. That is possible, but keep in mind, it is not just out of blue Oracle decided to do that. It is real application cluster. You have to have enough CPU to maintain data consistency and avoid problem with your split brain and probably unexpected shutdown for your RAG databases. Be conservative. Don't be too much optimistic about how you're going to use Exadata and how many features you can use in Exadata. Probably on the first stage of the migration, you will be using lift and shift and probably will not use too many features of Exadata. So be conservative, probably think twice before deciding how many OCPUs you need. Capture workload for real application testing, it will be quite useful to create baselines of performance. And work with Oracle folks, they are ready to help, and technical team is just amazing. Keep in mind that all databases on ExaCC are real application cluster databases, and all databases will be encrypted. Less VMs is better. The best, if you have only one VM cluster, it is the best way to consolidate, because in that case, you are using all available OCPU. None is living idle on another VM cluster. Less containers is better by many reasons. Again, it is not only a consolidation of how you use your SGA and CPU, how many background processes you have, but also it is patching and maintenance. You have to patch each container and it takes time. And keep in mind the maintenance operation like creating of database or scanning a CPU are serial. It means you cannot create database and scale CPU on the same time. All operations are coming one after another. And Oracle patching infrastructure 4 times per year every quarter, and you cannot postpone or cancel it. That's you need to keep in mind. Deployment, check requirements, read it twice, be prepared to fulfill all the required requirements before deployment. Size and weight, check not only your data center and doors to data center, but also elevators, if you have elevators, to feed the Exadata Cloud at customer when it will be delivered. Electricity, sockets, and power. You need to understand what kind of sockets you need, how much power you need according to size of your ExaCC. Network, cables, length for the cables to connect your ExaCC to your switches to your network. IP addresses, DNS, NTP, everything should be prepared in advance. And network to OCI should have enough throughput because it will be flowing gigabytes of data during the deployment and every quarter when you need to patch and update software. Access to data center for Oracle field engineering, especially on COVID era, you have to probably prepare some, fulfill some requirements, put some questionnaire and everything else. So be prepared and prepare that some people to work with Oracle field engineers to assist with deployment. There's network engineer, somebody from data center, sometimes somebody from DBA team as well. And as we know, now difficult times, delivery can be delayed. So keep it in mind as well. The schedule is question for real life. So real life sometimes sometimes make it impossible to keep tight schedule. OCI tenancy, don't leave it to the last day. Sometimes what I saw, people getting invited to create a tenancy, usually a week before deployment, and they're waiting. Don't wait, create OCI tenancy. Sometimes it takes up to 1-2 days to activate it. And as a matter of fact, Oracle field engineer will come to your site and they will, okay, guys, let's give us access to the tenancy. And if they don't have access to the tenancy, they have nothing to do, right? They have to have access. And it means lost day, for example, for Oracle field engineers. And Oracle folks work late hours, be, again, people to work with Oracle field engineers, somebody from data center, somebody from DBA team, sometimes not for all stages. Sometimes it requires work after hours. During the deployment, one of the main problem is network. Try to use standard configuration and try to not request from Oracle to bend backward because you have requirements for firewalls and everything else. And so try to keep it as recommended, and because less customization you have on network layer in connection with ExaCC, less problem you can expect in the future. Prepare SSH keys, configure SSH and TNS access to Exadata VM cluster in advance, and compartment. Think about your OCI layout. Layout for ExaCC, number of VM cluster, try to keep it minimum. Backup strategy, decide how you back up your database, encryption keys, and everything else. It is important. Layout for ASM, decide whether you want to use sparse ASM disk group for snap clones or not. Sometimes if you have requirements to have tons of clones of the same database, it makes sense. Keep in mind that sparse ASM disk group is copy on write, so performance is not going to be the same as normal ASM. Number CDB in the cluster, keep it low. Version 12.2 and higher, multiple reasons, especially considering pluggable databases, character set, and encryption. Multi-tenant, use multi-tenant for consolidation. Dev QA and performance testing, that you have to lay it out. Sometimes performance testing require isolated environment because of noisy neighbors. DR strategy and active data guard. Think how you can use the active data guard for reporting. If you have it, use it. Local file system is limited, 900 gigabytes per node. So number of container databases equal number of Oracle homes, keep it low, easier for patch. Again, less homes, less patching. And transparent data encryption keys policy is rotating policy, backup policy that has to be decided in advance. Security, OCI identity management, because you have OCI part and you have VM part in your on-prem. So that is part of security as well. Least right approach, as usual, less, you don't need to grant everybody OCI admin. Access as user OPC to VM cluster as an exception. Everybody should be connected with named accounts with sudo, and be careful with sudo. It is easy to break, very hard to fix. Integration with Active Directory, usually what I saw, it is Jambox. You integrate Jambox with Active Directory and you connect with named user to ExaCC VM. Auditing and monitoring is extremely important. Encryption on REST and transit, you are using transparent data encryption and REST, and by default, Oracle native encryption and transit. Password management, it is your responsibility. TDE key backups, it is your responsibility. And backups policy itself, it is your responsibility. You can use database vault. Keep in mind it apply a lot of restriction what you can do inside database as a DBA. Planning, migration planning. Try to use unified approach. Stick to that. Don't try to migrate each and every database by unique name. It creates a mess and a lot of errors in executions. Consolidation, again, use multi-tenant inside minimum number of containers. Acceptance and performance testing, create baselines and decide how you do that. Make a room and schedule as usual. Be realistic. Some stuff happens and some steps will be delayed. Use automation as much as possible. For example, zero downtime migration tool. A week ago, I was presenting about zero downtime migration tool. Great tool, can be used. Proven technology, we migrated databases with them. Use runbooks, test and repeat, rinse, test and repeat again. So prepare staging area for backups in advance, prepare the tools, integration points, gather information about your database to do not be surprised when you realize that some database is using export, classic export, exp, and it is not working with transparent data encryption. Job maintenance and schedule, cron tab is disabled by default on ExaCC. So think how you do it by another way, maybe the DBMS schedule or maybe some other third-party tool like Control M or anything like that. Backup tools, you have several options. I'm not going to deep dive to backup tools here, but you have to choose how you backup your databases, right? You use either third-party tools like Commvault, NetBackup, or you use integration with a ZLDRI device, or you can use NFS. Migration options, Oracle Data Pump, logical export import, long cutover, transparent table spaces, sorry, not transparent, transportable table spaces, combination of Arman and Data Pump, better.
Gleb, 5 more minutes.
Thank you. Cross-platform transparent table spaces, transportable table spaces, combination of TTS and Arman convert. It is for different engine. If you have different engine, probably it is the only way how you do that. Or use Golden Gate logical replication. Minimum downtime, a lot of requirements for source database like primary keys, supported data types, and difficult to set up. For the same engine format, Oracle Data Guard, probably the best choice. Oracle ZDM is using the Oracle Data Guard plus automation script for that. Typical scenarios, for example, you have the same endian format, 11GR2 or 12102. You set up ZDM, run migration job, encrypt table spaces, verify, you are done. If it is 12.2 or newer, the same endian format, Linux 86, set up ZDM, run migration job, verify, everything is done automatically for you. Source 12.201 and target 19.7, you can use ZDM. It is not supported, but it works. So you run migration, switchover will be aborted because it is data guard, different version of database. You start up upgrade, run upgrade for the database, then run utlrp.sql. And after that, usually in like 95% of cases, everything works fine. It is your database already on ExaCC migrated and your desired version. But if you want to consolidate, in the problem with that approach, it will wipe out destination database and restore from backup and create a data guard. But if you want to migrate one non-CDB database as a PDB in the target container database on ExaCC, this a little bit different approach. You prepare staging database with the same version, run migration using ZDM or data guard. It is up to you. Yeah, I would use ZDM. Then you upload that database using DBMS PDB describe package procedure to XML file, and then plug it inside destination container database. Then you run upgrade for that, plug it PDB, and run non-CDB to PDB SQL inside that PDB. And as a result, you are getting PDB inside your environment. And cross-platform transportable table space migration using incremental backup. You have you create a backup, create data file using Arman convert, and then apply incremental backups on top of that, and then you switch source database read on remote, export, import, and encrypt. So who and what is patching? Oracle operations team patching every quarter, storage servers, compute nodes, network PDU, and ILOM. You are patching compute nodes, operation system, grid infrastructure, database home. You are responsible for database backup, encryption, key backups, monitoring, performance, and resource management. It is your responsibilities. So it is not long list of tasks, but still you have already offloaded a lot of infrastructure work back to Oracle operations. And 4 times per year, Oracle operation will reach you and ask, we are going to patch your ExaCC. Tell us when it is convenient for you. We need 10 hours. It is, you need to find that time and provide that time to Oracle operations. Some common challenges, I have 2 minutes. That my challenge time. Transparent data encryption. I found a lot of people are not exposed to technology. It is not simple and it is not difficult technology, but you have to get used to that. Some skills are getting with time. ASM and storage management. In many companies, what I saw, they are moving to ASM. They haven't used ASM before. It is kind of challenge. Multi-tenant in combination with transparent data encryption is a challenge for people. Exadata features like HCC, some people haven't used it ever, don't know how to use it, don't know how to implement it, and what kind of benefits. Resource management, consolidated environment resource management is extremely important. Operation system management, CLI tools, third-party tools compatibility. That as challenges for DBA. For application team is consolidation and multi-tenant. It is slightly different connection string and integration points. Performance acceptance isolation, another challenge for application team. And again, new features, partitioning, compression, and business continuity in rack and data guard. That is for application team to adopt and implement in the code. For management, patch and schedule for DBA is extremely important, resource management and OCI management as well. Communication with Oracle operations. Try to communicate as much as possible. Everybody trying to help you. Nobody is working against you. That we need just to keep in mind. For finance and planning, CPU scaling up and down, billing and OCI governance are important because you don't want to pay because somebody is increase your CPU allocation to 100 and forgot about that. You will get a huge bill from Oracle by the end of the month. And security task lists and changes, integration with Active Directory, access to VM service, firewall, third-party tools, OPC account and keys, TD keys management, network certification if you want to implement SSL. OCI governance and audit is extremely important. Password policy for operation system and database privileges. It is for security team in working together with DBAs. So future planning, ExaCC you are getting for 4 or 5 years, and you need to plan your future right away after you migrated to ExaCC. You probably need to plan additional capacity. Is maybe what you're gonna do after your contract expired in 4 or 5 years. Are you going to public cloud, or are you getting new ExaCC, new model and move there? So that is up to you, and it is quite interesting what you decide. Thank you very much. I'm 1 minute late. I'm sorry. Here my email, Twitter, and my blog. Thank you very much. Do we have questions?
And hi, Gleb. I cannot see any questions coming through the Q&A yet, but I remind everyone that the replay of this session will be available for 2 weeks, and anyone can interact with Gleb by posting questions or comments in the replay page of the session for the next couple weeks. Yep, I cannot see any questions coming. Saying that, Gleb, thank you so much for sharing your knowledge like always. Excellent presentation, and have a wonderful evening in your side.
Thank you very much.
Bye, everyone.
Bye.